Hello, this is Mr. Henry, and welcome to lesson 2.1. In this lesson, we're talking about using integers and rational numbers, and we're going to compare and graph them and see just a little bit about them. This is our chapter on computation. It's going to cover positive numbers, negative numbers, fractions, decimals, a little bit of everything you're going to need to be successful in the rest of Algebra 1. Okay, so the Get the Goof asks you to find what are each of these numbers as a fraction. So let's see how we did here. 0.25 is not 2/5. This is probably one of those decimals you should probably know in your head. 0.25 is 1/4, like 25% off, 25 cents out of a dollar, 1/4. -5, they have -5 over -1, which is almost correct. The way you turn any whole number into a fraction is you just put it over 1, not -1. The third one here, 1 as -8 over -8, could be correct. The number 1 is really just any number being divided by itself. So -8 divided by -8 does equal 1. So this one's actually correct. There's easier ways of writing, like 1 over 1, or 2 over 2, or 3 over 3, but that works. The third problem here, if you remember, the way you change a mixed number to an improper fraction is you take the denominator times by the whole number and then add the numerators. You kind of go in a little half circle like this. You go 4 times 2 is 8, plus 1 is 9, and the denominator stays the same. This is the fraction. Yes, it's improper, but that's the fraction. And the last one here, the fifth one, 9/5 is already a fraction. It does not need to change. This is already a fraction. Okay? So let's take a look here at some of the vocabulary. We have a bunch of them for this lesson, but they're all fairly easy. So starting with a whole number. Whole numbers are numbers like 0, 1, 2, 3, 4. They're like how many people are in a room, how many sheep there are in a field. It's the simplest type of number, the number you learn about when you are first learning how to count. Okay? Then we have our integers. Integers are those same numbers, but now we have positives and negatives. So -4, -3, -2, -1, 0, 1, 2, 3, 4. You'll notice in both whole numbers and integers, there are no fractions, there are no decimals. It's just whole numbers that are both positives and negatives. Opposites. The opposite of two numbers are the numbers that it's two numbers with a different sign. So like a +3 and a -3. Those two numbers are opposites. Or 19 and -19 are opposites. Absolute value has kind of two definitions. The first definition I have here, the make the number positive, that's like the elementary school definition. That's the way like most people remember it, but it's not the actual technical definition. Most people remember, oh, you just make the stuff inside the absolute value bars positive, which, by the way, these are the absolute value bars. It's just kind of straight up and down parentheses kind of. But the actual definition is not just make the number positive. It is the distance that number is from 0. And because distances are always positive, that's why we kind of make the number positive. And finally, a conditional statement, which is going to come up a bit later on, is an if-then statement. Like, if it is raining, then you need an umbrella. That's a conditional statement. But we're going to see them, obviously, with math and not just like raining and umbrellas. Okay? So none of these words are terribly hard by themselves, and we'll see how we get through this lesson. So here it wants us to graph the following numbers on the number line, and it says which is the largest and which is the smallest. So if we take these numbers here, and we want to put them on this number line someplace, well, first thing I would do is I would find out what my smallest number is. Now, when you're talking about positives and negatives, the smallest number is the number that has the most negatives. The more negatives a number has, the smaller it is. So out of these, -4 is the smallest. And I'd put the smallest down here someplace. That's fine. Now, we kind of continue counting. Now, where would -2 be? Because this is really the next smallest number. Well, -4, -2 would actually be this way. -2 is bigger than -4. It's closer to our next number, 0. So as you're getting this direction to the right, you're actually getting bigger. So -4 is smaller than -2, which is smaller than 0. And these last two numbers should be pretty easy. 1 would go there, and then 2, 3, 4, 5, 6, 7 would go there. Now, I'm going to fill in missing numbers in between just to help out here. -1, 2, 3, 4, 5, 6, 7, 8, 9. So these were the numbers that we had to figure out. And then the question asks us, which is the largest and smallest? Well, the biggest number here, the largest that we had to highlight, was 7. And the smallest was -4. So the thing to remember about negatives, again, is the more negative, the smaller. So -4 is the smallest of those numbers. Letter B. We want to know which of these numbers is bigger or smaller. Is -7 bigger or smaller than -3? Well, if you remember what we just said a second ago, the more negatives, the smaller. So this number here is smaller than that number here. This one's bigger. So the correct symbol to use is this one. You pick the one that opens towards the bigger number. My teachers always said, like, imagine like a little alligator. An alligator would rather eat like a gigantic wildebeest instead of a tiny little mouse. So it'd rather have the big meal than the small meal. So it opens towards the bigger number. All right. Letter C here, I'm going to have you do on your own. It says here, how do you know which number is the biggest or smallest? If you could please write down a sentence or so describing how you know which number is bigger or smaller than another number. Okay, so hopefully you're done. You should have written down an answer for yourself. So you should have said something like, if the numbers are positive, then pick the biggest one. So if the numbers are positive, obviously it's easy to tell which one's positive and which ones are bigger and smaller. If the numbers are negative, the more negative, the smaller the number. And I guess you could always say that any negative number is smaller than any positive. positives are bigger than negatives. And that's always going to be true. Okay, so that's a quick way to tell which numbers are bigger and smaller. If the numbers are both positive, just pick the bigger number. You know which one's bigger. If the numbers are both negative, the one that has the more negatives is the smaller one. And if one's positive and one's negative, obviously the positive number is going to be bigger than the negative. Okay. So what we have here is we have a little table we want to fill out. So I'm, for example, giving you the number 8. And I want to know, is this number 8 a whole number, an integer, and or a rational number? So let's see. Whole number. Is 8 a whole number? Yes. That's like the number of people in a room. Is it an integer? Is it a positive or a negative whole number? Yes, it is. Is it a rational number? Now, this number we didn't talk about yet. A rational number is any number you can write as a fraction. Could you write 8 as a fraction? The answer is yes. 8 over 1. Now it's a fraction. So rational numbers are fractions. Integers are positives and negatives. And whole numbers are just positives. And these are both without fractions or decimals. So let's check out this third one. Is this a whole number? Well, clearly no, it's not. Is it an integer? No, because it still has decimals. You're not allowed decimals in integers or whole numbers. This is the tricky one. Is it a rational number? Could you write that number as a fraction? If you think about it, you might be going, no, I don't know how to do that. Well, even if you don't know how to do it, the answer is yes, it can be done. This number as a fraction would be negative 3 over 10. 3/10. This is read as 3/10, and it's negative. So we can write that as a fraction, so it is a rational number. Now, I'm going to give you two numbers I'd like you to try. So here's 2 and 1/2. So fill in the yes and no's. And the last one is negative 18. So go ahead, pause the video quickly, do those two problems, and see how you did. Okay? So whole number, no. Integer, no. You're not allowed fractions or decimals in whole numbers or integers. This one you're allowed fractions. Could you write 2.5 as a fraction? Well, yeah. That would be 5 over 2. And lastly here is this negative 18. Is this a whole number? No. Is it an integer? Yes. Integers are, you're allowed to have those negatives as well. And rational number, can you write that thing as a fraction? You better believe it. Put it over 1. Negative 18 over 1. Okay. So the next thing we're going to get to, now that we can classify these numbers a little bit, which is going to come up again, we want to be able to put them in order from the smallest number to the largest number. So let's see here. Here we have a list of numbers, and we want to put them in order from the least to the greatest. The way that works best is to write each number as a decimal. So if anything is a fraction, you put as a decimal. Now here we're in luck. Nothing here is a fraction. So now we could just go ahead and put them in order. So the smallest number would be the number with the most negatives first. So which number has the most negatives? Negative 2. So that is the smallest number. Okay? The next smallest would be negative 1. Because now we have only positives left. Now you got to ask yourself, what's smaller? Because we're trying to put the smallest one next. What's smaller? 1.89 or 3? Well, 1 point anything is smaller than 3 point anything. So 1.89 is smaller than 3. So this is what we'd get if we put those numbers in order from the smallest up to the largest. Letter B. Same deal, except this time we have a fraction in there. Do you know what 1/2 is as a decimal? 1/2 as a decimal is 0.5. That's another one of those fractions, decimals you should have memorized in your head. So now we can go ahead and put these things in order. So I only have one negative. That means he's got to be the smallest. Okay. Now, I have 3 other numbers. So let's see here. Let's see what happens if I line these up. So if I have a 0.5, that's him, 0.76, and a 4.5. We're trying to find which of these is the smallest. Well, clearly the guys that start with a 0 are smaller than the 4. Okay. So then we'll go to the next number over. We've got a 5 or a 7. Which of those is smaller, 5 or 7? Well, the 5. So 0.5 is our next smallest number. Then what? Well, out of these two, 0.76 is smaller, which would make the 4.5 the biggest. Alright, so if you have a fraction, change it to a decimal, and then put your decimal in order from least to greatest. Go ahead and try these 2 problems right now. Okay? If you haven't done the video, or if you haven't done the problems yet, pause the video, do them on your own, and let's go through them. So these are 2 more fractions that you should have memorized. 2/3 is 0.6 repeated, and 3/4 is 0.75, and because we have this negative, negative. So that's what these are as decimals. It's much easier to order decimals than it is fractions. Okay, so now we have them all as decimals. So let's see, which of these is the smallest? Well, we've got 2 negatives. We've got a -2 and a -0.75. Out of those 2, -2 is smaller. Okay. Now there's only 1 negative left, so that means he's the next smallest. So we've got 2 numbers left, 0 or 0.6. Well, hopefully you're understanding that 0 is smaller than 0.6, which makes the 0.6 repeated the largest. And letter D, you're in luck. Look, they're already decimals, so that saves you a step. So now you've got to figure out which of these is biggest and smallest. You could probably do it in this line, but I'm just going to write it up and down just for show. Alright, so you can see we've got 2 negatives. So those 2 guys are going to be smaller than the 5.3 and the 3.6. Now, out of those 2, we've got to figure out which one is smaller. The smaller negative is the one that has more negatives. So which of these numbers has more negatives? 2.1 or 2.9? 2.9. So negative 2.9 is the smallest. It has the most negatives. Out of these 3 numbers that are left, this is the only one that has a negative, so that is the next smallest. Out of the 2 numbers that are left, we've got a 5-point something and a 3-point something. I hope you understand why 3-point is less than 5-point. And lastly, 5.3. Okay, so being able to put decimals and fractions and whole numbers and positives and negatives in order from least to greatest is a good skill to have. I would like you to do numbers 1 through 5 from the textbook. They come from page 64 and 65. Go ahead, pause the video, do these 5 problems on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, 1 through 3 say graph the numbers on a number line, then tell which number is greater. I'll be honest, the graphing on the number line is really not needed. But being able to tell which one is bigger and smaller is very important. So out of 4 and 0, which number is greater? Well, 4 is bigger than 0. So 0 is less than 4. Between 2 and -5, which number is greater? 2 is bigger than -5. So -5 is less than 2. 2 is bigger than -5. And number 3, between -1 and -6, which one is bigger? Because now they're both negatives. The more negative the number is, the smaller it is. So -6 is smaller than -1. -6 is less than -1. Okay, down in 4 or 5, it says tell whether each number in the list is a whole number, an integer, or a rational number. Then order the numbers from least to greatest. Okay, so this guy is a whole number. He is not a whole number. He is not an integer, so that means he is a rational number. He is an integer, because he's negative. And 0 is a whole number. Now put them in order from least to greatest. Okay, so the smallest of them is -2. The next smallest is -1.2. Now we're out of negatives, now we're going to positives. I've got 0 or 3. Well, 0 is smaller, and then 3 is the biggest. Out of these, okay, whole number, integer, or rational. Well, this is not a whole number or an integer because it has a decimal, so it's rational. This guy clearly can be written as a fraction, so it's rational. Not a whole number, not an integer, rational. Not a whole number, not an integer, rational. So all of these were rational numbers. One of them is a fraction that to put these guys in order, we should change to a decimal. In fact, I even think we had this one on the last slide. -3/4 is a -0.75. So now, if we line them up and down, we get a 4.5, a -0.75, -2.1, and 0.5. So which of these is the smallest? Which one has the most negatives? Well, -2.1 is smaller than -0.7. So -2.1, and then -0.75. So that takes care of our negatives. Now we've got positives, 0.5 or 4.5. You guessed it, 0.5 is smaller, which makes 4.5 the bigger. Okay? So we had more practice with identifying if it's a whole number, an integer, or rational. Whole numbers are only positives without fractions or decimals. Integers are positives or negatives without fractions or decimals. And then rational numbers are any number you could write as a fraction, which in this chapter I think is going to be pretty much everything. Now, example 5 here, or I'm sorry, example 4. We're just going to do a couple quick practice problems of finding the opposite of a number and the absolute value. So for example, here in letter A it says y equals 4. So we have this number 4. Here we have a negative y, which means we want to find the opposite of y. So what is the opposite of 4? Well, it's the same number, you just switch the sign. So now it's a negative 4. So in the opposite, you switch the sign. The absolute value, the definition we had two of them, was make the number positive. So whatever the number is, the answer will be a positive that. So here we have a 4. So the absolute value of 4, the positive of that, is still positive 4. You're not allowed to have a negative number for an answer to absolute value, which actually comes up a lot towards the very end of the school year when we're talking about doing absolute value of like equations and inequalities. You can't have absolute value equaling a negative. It's against the rules. Letter B. If y is negative 3.2, what is the opposite of y? Well, if you take that number and change the sign, you'd get a positive 3.2. And then the absolute value, make the number positive. The answer is always positive. Would still be a positive 3.2. Okay? So when you're doing the opposite, you change the sign. When you're doing absolute value, you make it positive. And if the number is already positive, like it was here in letter A, you leave it positive. Go ahead and do letters C and D right now. Pause the video, do it on your own. All right, letter C. The opposite of this, well, this is a positive, so the opposite would be a negative that. So negative 2 2/3. Absolute value, better make that thing positive, so hopefully you have a positive 2 2/3 as your absolute value. And finally, letter D. What is the opposite of 0? Well, I might have fooled some of you. There's no such thing as a negative 0. That does not exist. It's just 0. And then the absolute value is still 0. I mean, that's kind of like the positive form of that number. All right. So now we've talked about absolute value and opposites. Opposites, you change the sign. Absolute value, you make the number positive. The last thing we have to talk about in this lesson is those conditional statements, those if-then statements. So here it says, if a number is positive, then its absolute value will be positive. Here's what I want you to do. I want you to underline the if part, and then underline the then part as two separate underlines. The if part is called the hypothesis. The then part is called the conclusion. It's almost like when you're writing a paper for com arts class. You start off with your hypothesis, or you have your idea in the very beginning, and at the end you have your conclusion. Well, the conclusion is at the end, the hypothesis is at the beginning. Now we want to be able to tell, is this thing true or not? That's really the whole point. The hypothesis and conclusion, it's kind of important, not really super important, but being able to tell if this is true or not is really the important part. So let's see here. If a number is positive, then its absolute value will be negative. Let's think about that. We can write down an example. So if a number is positive, then its absolute value will be negative. Is this true? So if I have the number 3, is the absolute value of 3 a negative 3? No, that's not true. Absolute value cannot be a negative. Absolute value will be, oh, I'm sorry, I guess I read that completely wrong. Then its absolute value will be positive. So if a number is positive, then its absolute value will be positive. Well, that is true. because absolute value is always positive. So yeah, true. That is true. Absolute value is always positive. Okay? Letter B. If a number is rational, which is every number we've seen today, anything that can be written as a fraction. So if a number is rational, so just think of one, then it is a negative integer. So I thought of a rational number. Here it is. Is that a negative integer? No, because this has a decimal in it. That's not allowed. I could also have a positive rational number, 2. That's not a negative integer. I could have a fraction, negative 1/3. That is not an integer. So this guy, I can come up with all kinds of examples where this is not true, which makes it false. So that's how I usually do these problems. If it says if a number is rational, I come up with an example of a rational number. If it says if a number is positive, I come up with a positive number. And then I check to see, is the second part true? Okay. With that in mind, I would like you to do letters C and D right now. Go ahead, pause the video, try to come up with some counter examples on your own. Okay, so let's see. Letter C says, if it is sunny outside, then you will get sunburned. Okay, well, if it's sunny outside, you will get sunburned. Is that always true? No. I mean, some people in here, some people watching may not really ever get sunburned. I mean, you could live in Alaska. Well, you can get sunburned in Alaska, but it might be sunny, but it doesn't have as many harmful rays. Or, I mean, you could be in a house. It's sunny outside. If you're sitting inside playing video games all day, you're not going to get sunburned. So this is not always true. So we say it's false. Letter D. If a number is an even number, then it is divisible by 2. So let's think of an example. If a number is an even number, so like 2 or 10 or 16, whatever. So if a number is an even number, these are all even numbers, then it is divisible by 2. Then it says then this guy could be divided by 2 evenly. This is true. No matter what even numbers you come up with, it will always be true because the definition of even means you can divide it by 2. So that is true. Okay. So we've looked a little bit at these if-then statements. You have your hypothesis and your conclusion. And the way we told if a number was, or the way we said if this was a true statement is we came up with examples of the first part and then saw, is it always true for the second part? If it's not always true, then you write false. Last bit for today. This comes from the page 67, numbers 8 through 12 at the top of the page. Go ahead, pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through it together and finish up the rest of the lesson. Okay. Number 8 says, for the given value of a, so it gives me the a, find the opposite of a and the absolute value of a. So basically we're doing those other problems. So number 8, I'll do it down here. The opposite of a, well, you change the sign. So instead of being a positive, it's now a negative. The absolute value of a, you make the number positive, so you get 5.3. Number 9, the opposite of a, well, if a is a negative 7, you change the sign, it becomes a positive 7. The absolute value is always positive. So you write down a positive 7. And number 10, All right. A is negative 4/9. So the opposite of that is a positive 4/9. And the absolute value is a positive number. So it's the positive 4/9 again. It's down here. Okay, so that's 8 through 10. Make sure you got it. I'm going to erase 3, 2, 1. All right, and now 11 and 12. So it says identify the hypothesis and conclusion. So this piece is the hypothesis, that's the conclusion. Hypothesis, conclusion. So the first part is the hypothesis, the second part is the conclusion. Got it, good. Really not terribly important. What's more important is being able to do the true or false part. And if it is false, give a counterexample. Give a reason why it's false. You can't just say, oh, it's false. So number 11 says, if a number is a rational number, so come up with an example or two. 2/3, 1/4, -3. There's 3 different examples. So if a number is rational, then the number is positive. Now, this one says right there, it does not have to be positive. So this is false. Because rational numbers are allowed to be positives or negatives. So that is false, and I have a counterexample. -3 is a rational number, and it is not positive. All right, number 12 says, if the absolute value of a number is positive, so the absolute value of a number is positive, absolute value of a number is positive. Come up with one more. So I use like a negative number, a positive number, a fraction. We use a decimal. How about a negative decimal? Negative 2.1 is 2.1. All right, so we have 3 examples here of the absolute value of a number is positive. In each of these, the absolute value of the number was a positive, okay? Then the number is positive. So that means the number I'm starting with was positive. Is that true? No. That one was a negative. That one was a negative. So that is false. Because I was able to come up with a couple examples that the number I started with, if I took the absolute value, I got a positive number, but the original number was not positive. So that is also false. Okay? So, the last thing we have for today is the summary. So, answer this question in a sentence. How do you compare positive and negative numbers? How do you know which one's bigger? How do you know which one's smaller? Take a minute or two, write a sentence or two. When you're ready to continue, hit play, and we'll go through it together. All right, here's what I came up with. So I said here that negative numbers are less than positive numbers. So negative is less than positive. And then if both numbers are negative, the more negative the number is, the smaller it is. And then obviously if both numbers are positive, you can tell which one's bigger and smaller. They're both positive. Okay? And homework comes from page 67. Numbers 2 through 16 evens, and 24 through 40 evens. This has been lesson 2.1. Thank you for watching.